Let's walk through a spider web. A couple years ago, we started working on the first elements of our digital textbook, Experience Controls. And one of the things that I introduced in the beginning of that textbook is this idea that you're never more than 8 feet from a spider. And that always kind of freaked me out, but also slightly fascinated me that you can be surrounded by these things that are everywhere, all around you, in the walls, in everyday items, and not really know it. And the same kind of goes for control systems. A lot of professors, a lot of us in education talk about how control systems are everywhere. They're all around you. They're critically important for you to understand how the world works from an engineering perspective, but we never really offer you examples of where they are, what they are. And so that's what I want to do today. Just going for a walk in my neighborhood, and let's see what control systems we can find. One of the first things you're going to see if you go for a walk in any neighborhood are a lot of cars nowadays. Cars are full of control systems. You've got ECUs, you've got all sorts of integrated systems that run the electronics of the car, the dashes. Nowadays there's hundreds of computers that are doing all sorts of things, from sat-nav and the traditional sorts of automotive elements that you have to more modern systems like the ADAS driver assist systems, all sorts of stuff. And so all of that has control in some respect, especially your assistance systems like radar guided cruise control. All that stuff has got a ton of sensors, a ton of actuation components, as well as a ton of control systems that are going to try to dictate how your system behaves and keep you safe. But there are elements that are even more basic than that. One of the best position control examples I like to use all the time are windshield wipers. They just go back and forth, but they're a great example of position control of a servo motor, whether you're using stepper motors or some of them I would assume might use DC motors. They're all around you. I used to actually work for a company making the elements that would lift your power windows up and down. Just everything you can think of in a vehicle. If it isn't mechanical, if it's not something that's physically happening, then there's a control system at work. Traction control, ABS brakes, all kinds of things. The other thing that you get with cars nowadays, especially some of the more modern electric cars like a Tesla, is tons and tons of systems that are governing the energy that goes on inside the car. You've got regenerative braking that goes through a 3-phase generation system, then that has to be converted into a voltage that can be stored in the battery, so it has to go in some kind of rectification or transformation system to have it not just the appropriate voltage, but the appropriate type of voltage for that to get into the batteries, and then vice versa. You've got DC batteries. Typically in electric cars, you're running AC motors, so you have to convert that DC energy into an AC system. And even beyond that, some of the hybrid systems you have nowadays, those hybrid systems have both an electrical system and a gasoline system that have to be balanced, they have to be tuned. Cars are just chock-a-block full of controls. And not only that, check this out. Somewhere up here, airplanes, also full of control systems. I once heard from an interviewer at a company that was making control systems for jet engines that modern jet engines have something on the order of several dozen PID control systems, all cascading and intertwined to regulate just the turbines. And then you take into account all the avionics, all of the electrical systems that are running not just the actual airplane, but the entertainment systems, the food preparation systems, just hundreds and hundreds of control systems. And most of them are PID. And that's something that's interesting to mention, both in terms of cars and in terms of airplanes. PID control is just so fundamental to the way that the world works nowadays. I remember one of the things we like to talk about a lot as a company is that Carl Astrom, one of the researchers and teachers we've been working with for decades, he's always talked about how PID control accounts for something on the order of over 90% of all the control systems you'd encounter anywhere in the world. And that's probably not far off. There's just so many systems that take advantage of that simplicity and that easy tunability and performance and reliability and predictability of PID control systems, and they're everywhere. Something else you might not always think about are just modern smartphones. I'm recording this video on my smartphone, and while I'm recording it, it's got all sorts of controllers going on with the display settings, camera systems, the communication going on in terms of talking to cell towers, especially nowadays with 5G and all of the really highly tuned systems that are going on there to be able to have our communication systems work effectively. Not only that, I'm recording this on a gimbal that lets me tilt and pan and zoom and make sure that as I'm walking it's not too crazy. This gimbal system that's letting me do all sorts of these effects, this is also a really nice example of a PID control system and the ability for you to use these things in everyday life nowadays, in drones, holding it in your hand, and have that control system do amazing things for you. We're coming up to a main road now, and there's going to be all sorts of examples of control systems. I can feel it. I just saw a streetcar go by. Again, fantastic example of both speed control, electrical systems, and the ability for power systems to convert electricity into different forms. Everything's full of it. I was trying to get a good example of a dump truck, but I wasn't able to catch it. But you can see here, this system here that's able to lift and manipulate bins. That's a perfect example of control. Both that and garbage trucks, cement mixers, a lot of the modern systems that we use for trucks that are doing construction or that are doing maintenance tasks or industrial tasks, they're using very integrated and very sophisticated hydraulic systems that need pressure control and all sorts of regulation to make sure that they behave properly. There off in the distance, you can see all sorts of other control systems at work. There are some cranes that are also useful for different types of applications of control. Probably mostly open loop, admittedly, but at the same time, I'm sure there's all sorts of systems going on there to regulate all the different elements that are in play to make sure that those behave effectively. Here's an interesting idea. Up here on this post, we've got a sign that tells you the speed that you're going at. Now, this isn't exactly a control system, but what this is kind of doing is it's giving feedback to drivers, who are sort of like a control system, on how quickly they're driving. So in fact, if you look at the person as the controller of the vehicle, then what this system is doing is giving them the feedback they need to control their speed. Score. Check this out. I found this construction site. This is going to give us even more control systems we can take a look at. You can see here there's all sorts of stuff going on in here, and everything, like I said before, is being pretty much controlled using at some point some kind of control system. I know a lot of it's open loop, don't get me wrong, but we've got pressure regulators, we've got those hydraulic systems I talked about. A lot of these may nowadays even be using some electrical systems that involve some regulation and some control aspects. Super cool stuff. Something else we talk about in our textbook in regards to vehicles is how the mechanical system that the suspension system represents, that spring mass damper system that makes sure that when the vehicle goes over bumps, like these speed bumps along this street, it has the right sort of feel, the right sort of comfort, and the wheels stay in contact with the road. That system is also a controller. It's actually very similar to a PD controller in that you have that stiffness and that damping that makes sure the vehicle behaves properly, but it's a mechanical controller. And that's something we don't really talk about all that much. Some of the first controllers, elements like you would have in an assembly line or in a factory back in the steam engine days, those were mechanical control systems too. One of the most famous being a governor, which is basically that spinning thing with weights on the side that would move up and down and open and close valves. Control systems is ancient, and control systems isn't just electrical. Thanks for coming along with me on my control systems adventure around my neighborhood. I hope you really enjoyed it. If you thought of any ones I missed, feel free to put them in the comments. I'd love to learn from your experience. If you have any other video ideas, put them in there too. Remember, control systems might be as common as spiders, but they're not nearly as scary. Take it easy. Control systems are old, but they're not nearly as dangerous.